ask your question in the chat box in this VC, or the WhatsApp group is also open for you to ask the question. So feel free. I can assure you all the technical queries related to Chenab. You can't get any better platform than this. So please get benefited. Sir, you can start.
How to share? I'm just finding it. Entire window I have to go and share entire window.
Yes, 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 sir.
Can you see my Can you see my screen?
No, no, sir.
Can you see my screen now? No.
No, sir, no.
Can someone help me how to maneuver?
It was just a minute, sir.
I pressed the share button.
Screen or window. Hello.
Yes,
Hello.
yes,
Click on share button and share
yes.
content. Click screen window or tab
Yeah.
and just click on below screen, entire screen, and just
Entire.
down button, downside button. Okay.
Uh,
Yes, now we
Yes.
can see your screen. Now you can go to presentation,
can you
sir.
can you see
Yes, sir.
Yeah,
Yes.
we can see your screen.
slide you are seeing? No challenges in design and construction of
No,
Chennai
no,
Bridge.
not slide because you have to click on the PowerPoint, sir. Probably you have not shared the entire screen.
So now,
You can stop. No,
Yes.
no, you can stop sharing and reshare.
uh,
Stop
We can see the
sharing.
screen now. We can see the screen here.
Yeah, we can see
you
the
can see.
screen, sir.
No, you are seeing my PPT. No, the challenges
Yes,
in
sir.
design and construction of Chennai Bridge. So I can start.
Yes, sir.
Okay. Good morning, all.
Start.
Good morning, all.
Yeah, good morning, sir.
Yeah. Now, the one question is, do you want to
Sir, I am
travel
not
above
able
the
to
clouds?
see the screen. I'm not able to see the screen.
Yes, sir, it is now cancelled. Earlier it was, I was able to see.
Yes.
No.
Sir, please
Vivek, are you
do
able
it
to see?
again, sir. Please click on share, sir, again. Share entire screen.
Sir, you click on share, then go to the entire, click on entire screen, and then again you have to click on the screen short small icon which is seen, and at the end there will be a share which will pop up. Correct.
Can you see
Now you
now?
can, yes, we can see the screen. Now you can go to PPT.
Okay.
Very good. Correct. We can see now. So
Yes.
please, you can present now, sir.
1 minute. Okay. Now, so do you want to travel above the clouds with your feet connected to the ground? This is the question. When you travel by aeroplane, you are above the clouds, but your feet is not connected to the ground. But if you want to travel like this,
Ronald
then
join
you
पण
have to go
आलाय.
by Chenab Bridge. This is the photograph of construction site when we are erecting the arch on a beautiful winter month. So the bridge is above the clouds. So now it is a good season for any one of you are interested to go above the clouds, travel to Jammu and take a train to Srinagar.
Yes.
Chenab Bridge is world's highest railway bridge and is a part of Udhampur Srinagar Baramulla rail link project, and it is located in Himalayas. They are young mountains, active young mountains, uh, and the temperatures goes to sub-zero, difficult to access, and sensitive border area. And these are the issues related to location. And this is the location of the bridge, and this is the Chenab Valley, and we have to construct the bridge. Not construct, we have constructed the bridge. But when you see the bridge, it is something like, but there is something behind the bridge, spirit of the bridge. What is the spirit of the bridge? That is the real bridge. That spirit of the bridge is new technologies and innovations. Here I will tell always one example. Implementing new technologies and innovations is not a joke. It cannot happen just like that. One example is, suppose you want to cook a nice dish and impress your fiancé or fiance. How do you do it? Do you call her and then prepare just like that and give it to her? Then she will throw you out. So same is here also. So then what do you do to impress her? First you will go through the recipe, how to prepare, excellent biryani or pasta, how to prepare it. Then you will get the best of the ingredients and resources. But with that, will you go ahead? No. You will make a trial first. Once one or two trials you make before calling her and make sure that everything is perfect. Then you will call her and prepare, you know, and then impress her. So all these steps have to be followed when you want to implement or bring in new technologies and innovations seamlessly. And this has been done in Chenab Bridge, and that is the backbone. The process what I explained to you has been followed. Now, a bridge of this, my presentation is broadly in two parts. One is brief details of the Chenab Bridge and various challenges that have been handled. Then Chenab Bridge is located around 125 kilometers from Jammu, and of the 125 kilometers, 50 kilometers from Jammu you can transport the materials by uh, 40 feet trailers. Beyond that you have to transport material by, I mean, in a smaller trailers or trucks. So this is one of the challenge of logistics, and Chenab managed very well. And as when we started the project way back in 2004, our first set of engineers have gone to site on a horseback. There are no roads. In 2004-5, if you have to go to Chenab Bridge site from Jammu, it takes about 6 to 8 hours by road. Today, you can go by road in about 2 to 2.5 hours. And over a period of time, the roads have widened. We have double road, and the safety on the roads has been improved substantially. So these are the people involved. Northern Railways and Konkan Railways are the client. Contractor is Afghans with a joint venture, and the design consultant is from Finland, WSP Finland, and Leonhard Andra and Partners for Germany. Proof consultant is Scott Wilson, Kirkpatrick. Now they are AECOM, and Flint and Neil. Flint and Neil are the people who drafted the PS 5400 Parton on fatigue detailing. They are the uh, proof consultant for the steel structure, and they're really excellent. And we learned a lot because of them on fatigue detailing. And we have slope stabilization consultants, ISSE Bangalore, Professor Sitaram, and IIT Delhi, Dr. K.S. Rao and Professor K.G. Sharma. And Itasca was also engaged. Itasca developed UDEC and 3DEC softwares. But I'm very happy to inform you that the entire construction engineering is done in-house by Afghans. Construction engineering is not a joke. Again, this was done, many people are involved. They are guided by Mr. Girdhar, Deputy Managing Director, and Mr. S.B. Joshi is a very famous consultant across all construction companies. They are all involved. And many Afghans engineers were involved in construction engineering. So this is the general arrangement drawing of Chenab Bridge. And the central portion, the main portion is arch, which is 467 meters span, and it is around 362 meters above bed level and taller than Eiffel Tower. And most important is there is also on the approach viaduct there is a transition curve. So transitions in anywhere is the most difficult part to handle. I even give one general example. See, somebody smokes very well and he smokes almost 20 cigarettes a day. Fine. There's no problem for him. And he stops smoking cigarettes. There's no problem. But he will have serious problem in the transition from from smoking to stopping smoking. So in that transition period, he will have tough time. And engineering is also same thing. Everywhere it is same thing. So we have a problem in transition curve, and we have solved it. So the entire general arrangement of the deck is we have deck is continuous deck, and in arch portion it is 785-meter long deck, only one piece, and viaduct portion it is 530 meters. And for construction of this Chenab bridge, we have put up a cable crane which has a span of 930 meters, and between anchorages the distance is more than 2 kilometers. And this is the arrangement we have created. Highlights of Chenab bridge is world's highest railway bridge. Design life is 120 years. Normally we design bridges for 100 years, and some part of the world they design only for 50 years. And we have done incremental launching of deck on a combined circular and transition curve for the first time in the world. And we brought the world's largest capacity crossbar cable crane. This is the first project based on my knowledge. It is where extensive wind tunnel testing is done. Topographic, section model study, aeroelastic model studies, they are done for the first time.
Sir, we are unable to hear your voice. Srinivas sir, you are not audible. I think there is some internet connectivity issues. I am just trying to speak with Dr. Srinivas. Please bear with me.
I'm sorry, there is some problem in network.
So you can continue.
Can you see my screen?
Yes, sir.
Yeah. And we have done, this is the again perhaps first bridge in India where we have done extensive fatigue design and detailing.
Sir, we can
Fatigue,
see your screen, but the presentation is not seen.
uh, 1 minute. No, screen means 1 minute.
Screen means this VC attendees are seen, not the PPT.
Okay, 1 minute.
Probably you have not done a full sharing.
Can you see my screen now?
Sir,
Presentation.
screen is visible, but not the PowerPoint.
How come?
Yes, now it is coming. Now you can present, sir.
Okay. Now, fatigue design and detailing is done for the first time in this company, in this program, in country. And most important is after we started fatigue design and into the issues, Indian Railways have issued a correction slip to the Steel Bridge Code of Indian Railways IRS Steel Bridge Code. They have changed and they incorporated the clauses for fatigue design, and in fact they brought an appendix for that. And we have done installed double corrosion protected bar and cable anchors for the first time in India. Again, then we have used 10.9 grade, that is very high strength HSFG boards we have used, and then we also did blast resistant design and special considerations in the design. These are like design challenges. So geographical location near zero temperature, so we went for special structural steel. Seismically active area, we developed the site specific response spectrum, and we have went for dynamic analysis of structure and we have done ductile detailing of the structure. Geologically, strata is very, so we have a very conducted very detailed geotechnical and geological investigations and extensive slope stability analysis. And in fact, slope stability analysis have been done before construction and during the construction, which is a salient feature of this project. And very high speeds are expected, wind speeds. So the system has been designed in such a way that if wind speeds exceed 90 kmph, trench will be stopped. So necessary instrumentation has been provided like that. And design is based on wind tunnel test. Then sensitive border area. Even if you remove one pier, the bridge will not collapse under self weight. So normally bridges will provide simply supported spans, but we went for continuous span. That's why you have seen we have provided 785 meters continuous deck on arch and 530 meters on the viaduct. And we built in redundancy. Suppose even if you remove one member, the entire thing will not collapse. Like for example, arch. If you remove the bottom cord, still you will be able to carry trains on the bridge. Similarly, even if you remove one diagonal bracing member, still you will be able to carry trains on the bridge. This is how the entire design has been carried out. These are the broad quantities. There are around 10,000, 10 lakh cubic meters of excavation, 73,000 cubic meters of concreting, 76,000 square meters of shotcreting, 90 kilometers of rock bolting, 30,000 tons in fabrication for permanent structure, and we have almost done another 10,000 tons of fabrication for uh, temporary works. And we have installed more than 3 lakhs of HSFJ bolts, and I am very happy to say that not even a single bolt hole has been re-drilled. It's a it's a commendable job done by the fabrication team. So this is the incremental launch deck with combined circular transition curves, and the launching was done in two parts, one from the abutment side, one from the other side. When we did launching from both sides, this joint we call it golden joint where they meet, and they have to come within an accuracy of 3 millimeters. You know, so that is the levels of tolerances we have achieved. So this is the left bank with 6.3 lakh cubic meters of earthwork, rock bolting, and these are the details. But when people looked at it, they had a doubt whether this can be excavated to a proper shape. The slope is almost 50 degrees steep. So, in fact, a question ridiculing whether you are able to do it was asked. It has been replied yes, and this is the finished bank. So, 215 meters plus another 40 meters below has been excavated and stabilized. And these are the foundations are constructed on the berms which are meticulously planned. So this is arch erection in progress on left bank. This is the right bank. Right bank is relatively weak when compared with the left bank, and so it has been provided with precious rock anchors, rock board, rock anchors. This is the fully stabilized right bank and arch erection in progress. And arch erection is completed, and this is bridge has been completed, and platform for blast protection has been installed, and it requires special expansion joints on the bridge and special expansion joints on the
केलं
railway
काय
track.
पोस्टिंग केलं आपण
They have been obtained from
स्पीड पोस्ट
Foslo
कधी
from
हे 12 मध्ये ना
France.
आणि त्याला भेटलंय त्या
and
आउट फॉर डिलिव्हरी का दिल्या
some
आता
officials are inspecting.
दुसरं का
Yeah,
होतं
you are having all latest photo of trains running on the Chenab bridge. So that's all the
जरा
journey.
ओपन कर तुझ्या इथं स्पीड
Now let
पोस्ट
me take you through the challenges handled. So to start with the geotechnical investigations.
स्पीड पोस्ट ट्रॅकिंग कर
So I'm not going to talk about routine investigations like boreholes and all, you know. But in Chenab Bridge, we have left bank and right bank. You see how steep they
ट्रॅकिंग
are,
कर ना
and
स्पीड
strata
पोस्ट
is
ट्रॅकिंगच
varying.
टाकायचं कधी
And people wanted to know
खाली बघ ना
what is the strata below the
हां ई एम
founding level of the
कॅपिटल
arch, which is most critical part.
एट फाय सिक्स
There
टू
we have
एट फाय
constructed
सिक्स टू
drift. So
थ्री
the
टू
drift is something like 2.5 meter
फाय फाय
diameter,
आय एन
like this. It has
हां
been excavated, and it is in the form of a cruise form. Uh, and it is about
खाली खाली बघ
7 to 8 meters above the
काय नाव आहे
founding level of the arch. Why it is above?
तू ते दुसरं स्पीड
So
पोस्ट हे नाही
during
ओपन हे नाही
excavation,
होत
the
बॅक
drift
कर
will go
बॅक
away.
कर
Otherwise,
खाली स्पीड
if
पोस्ट
you do
त्या
it
फर्स्ट
below the
साईडवर जा
founding
बरं
level, you are leaving a pocket below the foundation level and keeping the foundation in unsafe
सर्व्हिसेसमध्ये
condition.
बघ काय आहे ते
And you see, but there is no access road. You know, the entire all the components for drilling and testing have been brought by through this white,
खाली
which
खाली
is
बघ
called
खाली बघ
tracer path. People moved it by tracer path and then excavated the work and make
ई
this
एम
tracer path, I mean
एट
drift.
फाय सिक्स टू
So it is in the form
थ्री
of
टू
a cruciform,
फाय एट फाय
and in this we have done it is around 40 meters
हां
and this is around 30 meters. And then we have done the geological logging and we have done in situ plate load test and we also done in situ shear test, box shear test. And maybe this type of things people do in
काय आहे पण ते
dam projects,
कुठून आणलं
hydraulic dam projects, whereas in for type of bridges this is
नाव कोणाचं आहे
maybe for the first time. And these are
कुठून
the
आलं ते
different types of tests we have carried out.
कुठलं आहे ते कुठून कुठं जात आहे
You name anything, it is there.
आपण
Dilatometer
बारामतीला कधी
test,
पाठवले
MESW test,
तर
tomography,
त्याला पोचलं
all
त्याचा
these
मेसेज
things
करा ना
have
मला
been done, and the data has been used to understand the shape bearing capacity, settlement characteristics, and for the design of the slope stabilization measures. And challenges handled successfully is one of the challenges wind force assessment. I would like to say a very very interesting point. This I learned when I was working on missing link project, not in Chenab. We hello, can you hear me?
Yes, sir. Yes, sir. We
Yeah,
are able to hear you.
yeah. Then
Yes, yes, sir.
in see for aerodynamic stability of the bridges, we will consider the 10,000 year return period of the wind. Normally, bridge design we use 100-year return period, and for aerodynamic stability we use 10,000 year return period. Why?
Oh,
I'll explain later, but this is a very interesting fact, and we did lot of research and found out the answer also.
okay.
So this is a deep gorge, and because of this gorge, there is a what is called a Venturi effect. Then
Mhm.
wind speeds will increase. So those will be more than what is prescribed in the codes. So we have done a terrain model test. We created a terrain of 11-kilometer disk, that is 1 is to
Mhm.
2200 scale, and put it in a wind tunnel test, and then conducted the wind, I mean, by rotating the disk in a different directions to find out which direction wind is causes maximum and what is the maximum wind speed. Against a basic wind speed of 39 meter per second, we found a wind speed of 74 per second.
Oh,
So almost the wind forces will become four times. You all know that wind force is proportional to square of the velocity.
जागी होतात ना रे
So
हे मध्ये मध्ये
this is the
होतात
thing. Then
11 वाजता
to
झालं तर
assess the aerodynamic stability and also to assess what are the forces coming on the various types of sections, arch members and deck structure, and to optimize it, we conducted the what is called section model studies. And in the section model studies, we have considered two types of deck. Deck with alternative one, without nosing, and the one with nosing. And when we put the nosing, which is represented by blue line, you see the forces are consistently low when compared with red one without nosing. So in the arch portion of the Chenab bridge, we have provided this uh, nosing so that it improves it reduces the wind forces on the structure. Then we have done aeroelastic model of the full bridge. And then when we did this test, we found that the vortex oscillations, that is, the bridge is oscillating up and down more than permissible limits. So then one of the solutions was to fill up the arch with concrete. So arch members are originally box sections. So all the box sections were filled with, say, so-called free flow concrete to add to the weight of the structure, and with that the problem has been mitigated. And we have done site specific response spectrum. IIT Roorkee has done it. But I want to tell you a few things. There are many people question about such a very iconic structure being put up in a very sensitive area from earthquake considerations. If you closely look at the seismic zoning map of India, Chenab Bridge actually comes under Zone 4. But we designed for Zone 5 acceleration, that is 0.36 g. And the slopes have been designed for four different conditions, and normally we design only for two conditions. In Chenab Bridge, we have designed for static, construction stage, service condition, and with the design basis earthquake, service condition with maximum considered earthquake. And previously, we do not consider vertical seismic acceleration, but we considered vertical seismic acceleration also in the designs. Then this is the uh, uh, earthquake spectrum of Uttarkashi, which was very predominant, which was the most severe earthquake in the region. But as per IIT Roorkee, you see this is the earthquake spectrum we have considered, where the accelerations is 0.2, 0.25, so 22. In case we have considered 0.36 dynamic, and this spectrum is used for dynamic analysis. And the earthquake happened in about 6 to 7 seconds or 10 seconds maximum, whereas here we have considered almost up to 50 seconds. So with this type of most stringent spectrum, we have analyzed the slopes of Chenab Bridge. So rest assured, the slopes of Chenab Bridge are in safe hands. So excavation of slopes is a beautiful subject for me, and this is part of my PhD thesis. See, design of slopes, for that matter, any design, you know, I feel it should be holistic. Many times, design consultants say, "I have designed this structure. It is your problem how to construct." They tell the engineers, but that is not a right approach. The approach is the whole purpose of design is to give good for construction drawings. That is the bottom line. For that, they have to consider so many parameters. What is the execution schedule, methodology, materials, equipment, good engineering practices, and do you require any analysis? And during analysis and design, the designer will specify certain requirements. Do you require any monitoring during construction or after construction? So all these things you have to consider and develop the good for construction drawings. So I coined it as holistic design of slopes, and this has been really followed in Chenab Bridge. And then now I showed you a very steep slope we have to excavate. And when we started the initially, we were getting a progress of something like 5,000 cubic meters per month, and we have to excavate something like 600,000 cubic meters in the project in that area in the left bank. That means it is going to be 12-year project or 120 months project. Can we afford to take so much time? Then we came down with the idea top down method of excavation following contours. So what is the meaning of that? You strictly follow the contours and start work from the top. So top portion you please, this green portion is concreted, I mean supported and short creating rock bolting whatever it is required do, and this purple portion is where work is progressing. When I showed this drawing initially, people said no. I mean this is not acceptable. But finally we agreed that this is the only way. And then when you see next, as the work progresses, you see your work front is increasing. This purple portion is increasing, and you can have multiple portions to do the work. Then if you go further, this is how the work completed. And by following this method, what we achieved, not even a single untoward incident happened in the project during slope stability excavation on left and right banks. Not only slope stabilization in any area of the project, and safety was given highest priority. So, but this is not the only thing. This is how the left bank, this is the, but we have to create approach roads on the bank to access various berm locations, and also to train out the material at different levels. And this is the way the approach roads have been made and the slopes have been completed. And we have two engineers, very fine engineers, by name Mr. Tagore and Mr. Vijay Pai. In fact, they used to walk in front of the excavator in this figure, and they used to guide the operator that he has to move 2 meters up, 3 meters down, 2 meters left, 1 meter up. So, like this, they walked in front of the excavator and made the approach roads done. Then, open joints and cavities in the strata. There are open joints in the strata, and we cannot leave this type of open joints in the uh, Chenab bridge. And suppose, I'm telling you, I'm not joking, if you remove this rock, a person can go inside and stand there, sit there and do some tapas. He can do that. So this type of open joints are there, and we have pumped something like 5 lakh bags of cement to seal all these joints. Now, you may ask me, अब तो कुछ चोरी किया होगा, but if I do chori, it will be known. But the figures doesn't speak that way. The before grouting, we have the values of shear modulus and all, and after grouting, we assess the values. You see, the values have increased the by almost 2 to 9 times. Then this is the image, MSW image, before grouting. This is the image after grouting. This blue portion, there are no black spots. No, these black spots are the weak areas. So where we have done grouting 0 to almost 22 meters, there are no black spots. This is a proof that we made a excellent cohesive mass and filled up all the loose joints in the strata below the below all the foundations. And then now we made a statement in the beginning that the strata is highly varying. Now to start with the designs, we have the data from say trial pits or borehole data. Then came up with a basic question. You have taken a very small sample for the design and strata is varying, and how reliable are your designs? So then we told the client that yes, we will have a setup to do continuous checking of the designs as the excavation progresses. And for that purpose, we developed a prototype concept like design as you go. And in this work, what we did was we have purchased three sets of softwares of SWAGE and DIPS and provided to geologists. And this is the only site, perhaps, there are six geologists working at the site. And they are trained and they became half civil engineers at the end of the day. And they do geological logging, they do slope stability analysis, and if everything is fine, they will go ahead. If there is not good, they will revise the design. And in the slope stabilization work, we created more than 150 reports, construction stage reports. And this is the geological log we finally prepared after the complete excavation of, say, I think this is left bank. Then another challenge is incremental launching on combined circular and transition curves. So just I want to have a recap of fundamentals of curves. Can somebody tell me what is the radius of a straight line? Hello? Hello?
Infinite, sir, infinite.
Infinite. No, Vivek, you should not tell. I mean, students, it is infinity because
Sir,
some students
I
have
am
told me
also
it is
your
zero.
student, sir.
Yeah, and because some people said zero, so that's why I asked this question. So, what would be the radius of a transition curve? So, it, it is continuously varies. It starts from infinity and it comes to a particular radius. Transition curve is used to join two curves of dissimilar radius. So, normally incremental launching is done either on a straight alignment or on a curve of uniform radius. But in Chenab, on a transition curve, we have done for the first time on a curve consisting of transition and circular curve. It's a wonderful experience. And yeah, this is the drawing I prepared for myself to understand myself, how we are going to do the work. So this blue portion is the circular curve. This magenta is the transition curve. So what we have done is we launched on a circular curve of uniform radius, which is different from the radius of the original curve. And the key principle is when you are launching on a uh, launching curve, it will be away. It will be away from the original location in, and it will be inside of the transition curve. So these dimensions X and Y should be more or less same. Now, this figure, though it looks little ugly, I returned for what is called nostalgic reasons. And the deck is fabricated as per the bridge alignment and launched on a designed curve of circular curve. Now, here I would like to say something. So, we have done some work, Chenab, one time over. I have liking, if any student is interested, I can guide him how to develop this radius of this launching circular curve. If somebody is interested, I can help because in Chinab, one project I have given to a student of IIT Kanpur and he has done it and he got his MTech thesis out of that. Maybe this can be a BTech project work. Where why I want this is I want this knowledge to be within the country. You know,
Hmm.
now I am 60, maybe another 20 years I'll switch off. You know, but the knowledge should remain. So I want somebody to get into the details and do it. Okay. Then this is the finished bridge. Then installation of cable crane. Now for construction of the arch, erection of the arch, we require a cable crane. The pylons of the cable crane are something like 128 meters. Normally we can use a tower crane up to something like 50 meters, and beyond that, how do we construct? So how to construct this 128-meter pylon? That itself is a project, you know. And then putting the ropes on the top of it is another challenge. And there's a very old movie, which came in 1980s, Cliffhanger. Sylvester Stallone was the hero, and he climbs the vertical cliffs. So we copied from him. So we developed what is called a climbing crane. This climbing crane was developed by Mr. Kanolkar from, he is no more there, he is no more, from Bombay. He has designed this climbing crane, and we erected the portion which is possible up to 50 meters with the help of a tower crane, and after that the work has been handed over to climbing crane. What the climbing crane does is it will pick up the module from the bottom and put it here and erect it. Once it is erected, it will hold that erected module and moves up. So look at here. In this figure, you see there is no module has been erected. But in the next figure, you will find the module has been erected and the climbing crane has moved up. So this is a beautiful principle which something like we followed from Cliffhanger, and it actually moves up right up to the end, and we completed the pylon. Likewise, we completed pylons. There are four pylons. So these four, two on buckle side and two on cowrie side. So after completion of these pylons, now we have to put the cable on the top of it. Now, if I ask today people how to do that, people say bring helicopter and then we'll do it, or we can see some beautiful animated videos circulate about uh, uh, erecting ropes with the help of helicopters. But Chinab, we went by very simple engineering. The engineering is we have taken balls, steel balls, which can float in water, and then these balls are connected to winch with a 12 rope and then dropped into the river. So then the balls fell from both sides into the river, and somebody went with the help of a boat and brought the both the ropes together, and then we have a one single rope of 12 millimeters from one side of the bank to the other side of the bank. Then we'll have that to 12 rope we attach it 18 to 18 36 36 to 58 then we pulled the ropes from one to the other. Then the cable has gone from one side to the other, 58 thick cable. Then that has been put on the top of the pylons with the help of a cable crane, climbing crane. So that is how the pylon is ready, and then it has been connected to the anchorages. These are all gravity anchorages, and this is the cable crane which has been commissioned. The cable crane will have a crossbar. The weight of the crossbar is 6 tons. So capacity of each cable crane is 20 tons. So lifting capacity of the crossbar is 34 tons. Why this 34 tons? This 34 tons is relevant because when we are erecting the arch, the weight of component of arch should not be more than 34 tons. So that is the input from this cable crane design to the arch designer. That is where complete coordination with temporary works, mechanical works, methodology, everything should be seen together. We can't see them in piecemeal. Then, yeah, this is my. I'm going to show you the best photo of the Chenab bridge. It is like
Are
this. This is the
एवढं का विचार
reinforcement
करतोय?
for arch base. I call this as javelin reinforcement. It's a really jewel. You see, each bar is of different length, and it is in three different directions. Look at here. These bars are of different length. These are of different length. The vertical bars are of different length. And such a highly congested reinforcement. And developing this, imagining this, developing this, doing it, it's a wonderful engineering feat. And we had one engineer by name Mr. Arun Kumar. He developed the bar bending schedule for this arch base, which is running into 250 pages. Please understand. And then each bar has been tagged. Then, but how to do this? And what sort of inputs we have? The designer has given a drawing like this. Now, please tell me how to do this. And this is further complicated with I have to insert the anchor bars for the arch base, and these things cannot float in the air. No, these are very heavy, like they are, if I remember correct, 40 diameter Davidic bars, so they cannot stay in air. So for them, and they should be accurate position, so then they require some sort of stools. And how to place these tools without infringing with the reinforcement? That is another challenge. Then it is further compounded by the fact that the concreting has to be done in four different layers. It's a mind-boggling work done by Afghan engineers, but they went very systematically. How they went? The approach is first you develop virtual design and construction. So we have, then you make first run or mock-ups, then sit with the team and work out detailed methodology of work, then you follow the discipline. So we have a Tekla software, and using the Tekla software we have completely modeled reinforcement, and then we positioned everything so that there is no infringement. Then we made a mock-up. Please understand, I told you a recipe how to impress your girlfriend. So this is what we have done. We have done first a Tekla model, then we made a model with the color coding of the bars, And then these models have been shown to the workers to understand how they have to make this thing. In fact, we have made two mock-ups. One mock-up was made under the supervision of my manager, my engineer, Mr. Tagore, and second mock-up was made by the workers themselves. So we made two mock-ups. Then that is how after then we collaborative planning we made a teams and we tagged every bar with a number and the lifting sequence of the bars have been given and the bars have been lifted and brought to site. They are not done at the site, no, they are done somewhere 2 kilometers away from the bridge site. And so everything has to work flawlessly and that has been achieved. And finally, this is the jewel we made in this, but unfortunately this jewel is covered into the with concrete and it can't be seen. So this is the concrete base ready to receive the arch. So let me go take you through the arch erection. So this is how it is. And then as the arch progresses, so we started connecting with stay cables front and back, and then it goes like this. But then once all this is done, the arch is ready. So I am explaining you in a very simple thing, but this arch erection took almost 2 years and lot of engineering went into this. Then this is the joint in sky. You see how complex it is, and it has happened flawlessly. Not even a bolt, single bolt has been re-drilled in the sky. And this is another joint. And now, what is the precision we have achieved? See, one of the tallest pier is 140 meters, and the tolerances permitted is 1 in 1000. And the designer permitted 100 tolerance in any direction. But the what we achieved is 23 is the maximum deviation against a permitted deviation of 100 and this was achieved with a total number of 10,000 bolts in the system. So these numbers speak for the quality. Quality in where? In fabrication, complete planning, fabrication and erection. And let me tell you frankly, there is no shortcut. We went the hardest way possible and this is the result of hard work. Then this is the arch. When 200 meters on either side is erected in air, these are the tolerances we achieved. Against a deviation of 100 the maximum deviation is 39 Sometimes I wonder if I sit myself and take a big, say half a kilometer paper and start plotting it, maybe I may not get this type of accuracy. But this is the accuracy we have achieved in the project. That comes with tremendous dedication. Tremendous dedication. It is like, it is I'll always say, this is like a temple for us, you know. And everything has been done religiously. Religious means what? It is not that praying God, that sort of commitment and devotion, you know. When we are standing in front of God, I know you are completely devoted to Him. You don't think anything about any other thing. And we work for it. That sort of commitment gave this type of results. And this is the geometry of the base model and how this is achieved. I mean, you can't achieve just like that. So one of the things was the arch base module. When you are putting before that, there is a arch base plate. The survey, initial survey of this base plate is very, very important. If the base plate is slightly deviated, I mean, it will go somewhere when you go 200 meters into the sky. And this survey details have been monitored by none other than Deputy Managing Director of AFCONS. Unless he approves, we will not concrete. And for the survey, we have marked 12 points and measured the deviations and tried to adjust. And of course, nobody said how much, but we put a self-imposed tolerance of 5 millimeters in the positioning and worked on it. And then at the end of the day, in one of the things, we have at three locations, four locations, it is slightly more than 5 millimeters. And even this we tried to work in shifting, but there are something like there are 2.5 days we just trying to adjust. After 2.5 days we decided, okay, only some four minor things, let the problem comes, we'll handle it. Then we moved ahead. So this is the level of commitment shown by AFCONs, not only field engineers, by the deputy managing director of the project. And incremental launching on the arch. And this incremental launching on arch, it is on a straight line. You may say, what is great about it? Now, this is a very beautiful thing. It is on a floating support. See, when you are doing incremental launching on a normal bridge, the foundations don't move. Whereas the arch is provided with camber, and as you start launching onto the deck, the arch tries to settle. And because of the settling of the arch, then how do you manage? And still you have to achieve the camber. So camber management is the most important part of this launching of the deck, and it has been done. So this is how the launching has been done, and this is how it looks like. And this is the arch deck has been completed. And the challenges, another biggest challenge is safety. So for safety, we have what is called fixed lifeline installed all along the bridge so that it works by gravity. By any chance somebody is slipping, the rope will hold him. So like this. And we also made, hello, there is a crosstalk. Can you switch off the mic? And we made a platform for workers to work. And this platform is inspected by safety people before safety manager or safety engineer before any worker to go. And each working platform is provided with a tag. If the tag is there, worker will go. If tag is not there, worker will not go. And this is how we have done with zero accident. And National Safety Council of India, normally they give Visist Suraksha Puraskar, but looking at Chenab work, they added what is called Ati Visist. This is what they have given for Chenab in 2019. And we are coming to an end. So what was the challenge in the beginning? It has been created, transformed into a marvel. So how it happened? So it happened with this is the, artist impression of Chenab Bridge. So this is how we started, and we went with the end. So what people say, there is a book by name Seven Habits of Highly Effective People. Maybe I'll put it as seven principles should be of highly critical projects should be like start with the end in the mind. You know, this is what happened. We started with the end, and we achieved the end of this project. And before I conclude, thank you. And some of my whatever I have spoken, just 1 minute. Some of the things I put them in a blog, about 30, 35 blogs I put in Notes of a Snoopy at substack.com, and I'm going to post another 30 or 40 in the next 1 month. And I mean, you can access them. And I'll be posting them in LinkedIn. And from LinkedIn link, you can always access these things, or you can go there and access on your own directly. And this is my email ID, srinivasmantrala@yahoo.com. You can contact me anytime. Yeah. Now, any questions? So I'll stop the presentation.
हेलो, जाके पूछो ना उसको
Any
क्या क्या है.
questions?
मैं क्या बोलता हूँ,
Please,
पूछो सही गिफ्ट गिफ्ट क्या है वगैरह.
please avail the opportunity. Sir, very excellent presentation. Before we go on the question answers, because there are some questions which have already come. So uh, probably almost all the key aspects you have touched upon in Chenab project. Of course, the project is such a wonderful that you can keep talking for hours together. But then, in a limited 1 hour time, I think this is the best possible what you have done. Yeah, so should we start with taking the questions? I'll read out. There are some questions in the WhatsApp chat box, and there are few questions which have come in a VC chat box. So few persons are asking, will we get the PPT? So complete recorded session will be provided to you. Link will be provided to you. There is one question from Mr. Sam. He's asking. Which structural analysis construction stage simulation softwares were used during Chenab Bridge, especially for arch erection stages, wind load modeling, and cable crane operations? And how closely did your field measurements match the software prediction?
Uh, it's a beautiful question. I think we used sophisticated software for construction stage analysis, number one. And uh, we were measuring the uh, uh, what is called deflections of the tip of the arch during erection on a daily basis. And the survey will be completed before morning 8 o'clock. Before sun rises and it picks up the heat, we'll complete the survey part of it. That is one. Number two is during the erection, the consultant has given a guideline that if we are within 100 tolerance at any stage, we don't have to refer the matter to him and we
Okay.
can continue with the work. And and whenever there, see what happened is you have seen in the presentation, the arch has been provided with stakeables during erection at different stages. So even if we are within 100 everywhere, that means when we are at the time of erecting the stakeable, at that stage, if we are within 100 we can still we can adjust it to theoretical level
Mm.
at that point.
Mm.
And again, for the balance portion, again we have 100 like that, and we never went beyond 100
Okay.
Yeah.
Okay, so basically, Sophistic was a tool which was, between the site adjustments and theoretical calculations.
Yes, yes, yes.
Yeah, there is a second question coming by Mr. Rakesh Kumar. He is asking, what is a live load on what is a live load of a bridge? And second question is, how deep is the foundation And what type, open, pile, or raft? I think the second question is clear after the presentation. So you can talk
Yeah.
about the live load part.
Live load is basically two train loads. The bridges is designed for two trains. So we have taken MBG loading as per IRS bridge rules.
Okay, great. Yeah, then there's a second question coming up by Mr. Sanket Mali. He's asking, good afternoon. As you said, bridge is designed as blast resistant bridge. Then how the magnitude of blast is derived and assumed or considered? And in the same, he is asking a second question. What design speed of train bridge is designed for? So two questions. One is on blast load and another is on the speed, train speed.
Yeah. So the blast load has is two parts. One is contact blast, another is non-contact blast. So
Mhm.
the contact blast is like the blast is happening on the bridge itself. Okay,
Okay.
and it is like a 40 kg 40 kg TNT equivalent explosive is blast on the bridge deck. So these
Mhm.
forces have been given by uh, Ministry of Defense.
Okay.
And similarly, there is what is called uh, I don't say it is a normal blast. That is the blast happening away from the bridge. That is
Okay.
basically some 100 kgs of blast, kg explosive blast happening
Yeah.
some just 20 meters away from the bridge. These are the things. These details have been given by Ministry of Defense, and that
Mhm.
is one. Second is coming to wind. We designed for that design wind speed of what came from the wind tunnel testing, some 74 meter per second.
No, no, he's asking about design wind speed of the train. He's asking.
No, speed of the train is speed of the train is 100 kmph. The
Okay,
speed of the
100.
train is not a parameter in design. Actually,
Hmm. Hmm.
it's
Yeah.
yeah,
I think, sir, I would just like to add something which I remember after the visit of this Metro Man, Sridharan, sir. I think he wrote a letter to Modi, PM Modi at that time
yeah.
regarding adding some blast or something, right? If I remember. Yeah.
So
There is a next. Ha, sir. Please continue.
yeah, any question on that?
No, sir. I'm going to next question. It is by Mr. Nilesh Karwar. He is asking, could you please provide site-specific study report and wind study report for our understanding? Since such studies are generally conducted only for specific bridges, related data is not widely available. Having
Yeah.
these reports will very useful for us to understand the concept.
See, these are the things I cannot share. This is the property of Northern Railway. I mean, even AFCONs cannot provide also. I mean,
Probably they can do a MTech project under you, sir, your guidance. So probably in not directly the data, but the concepts can be taught or
yeah, yeah.
learned by them through you.
But no, but still it requires permission of Northern Railway.
Okay, okay,
Like
yeah.
when I did my PhD on Chenab Bridge,
Hmm.
for using the data of Chenab Bridge, I have taken permission from Northern Railway.
Oh, okay, okay,
So,
great.
yeah.
Yeah, there is a next question by Mr. Bhavesh. Sir, what we get the wind load modeling and study of wind assessment? Since for such location and height, it might be useful study for all of us.
Uh, I did not understand, but basically it is done through wind tunnel testing.
Okay, so not depending
And
just on the coral.
there are some clauses available in what is called uh, both British code, European code, and Indian code. But
Mhm.
I find it is not easy to follow them. It is like
Okay.
we gave a class just so that I mean I answered one point. I mean it really don't go very well.
Oh, oh, okay. Sir, who did the this wind study? RWDI or some other lab?
It is done by Force Technology Lab in Denmark.
In, okay, Denmark, Force Lab. Yeah. Okay.
For
There's
Chenab
another question. Ah,
and
sir, yeah,
for
please
missing link,
continue.
for missing link we got it both from RWDI Canada and the Force Technology Lab Denmark. Both they have done.
Oh, oh, okay.
Yeah.
Yeah, there's a next question coming from Mr. Abhijit Gawai. He's asking, first of all, sir, it was a gem full of presentation. Thank you for it. If you could share how structural health was monitored during construction and planned for after construction. So he's asking basically, is there any SHM installed for after construction?
During construction, we are at site continuously monitoring the uh, like settlements of the things or the arch erection. We are continuously monitoring the geometry of the arch being constructed. No other thing was done. But
Mhm.
after the arch is completed, before the bridge is commissioned, we have put a very systematic thing. We have put ground monitoring accelerators for movement to measure the seismic accelerations, and we have put anemometer on the top of the bridge, and we have put temperature sensors, and we have put what is strain gauges and inclinometers have been put to measure the uh, any inclination of the things. So
Oh,
all this have been done, and if any of the things exceed the set parameter, then it will go to stopping of the train also.
oh, okay. So the
And
monitoring and maintenance will be done by AFCONs or it will be done by Northern Railway in the foregoing
in
years?
the defect liability period, Afcons will take care, and after defect liability period, Northern Railway will take over.
Okay, okay. Yeah.
Uh,
Yeah, there is another question by Mr. Shailesh. He is asking which softwares are used at different stages of construction stage, geotechnical investigation to project completion for the structural analysis purpose. So I think you have already answered sophistic at the, I mean, construction stage and uh,
yes,
sir,
wedge and dips for stability.
S-wedge
Yes,
and
wedge and
dips.
dips. Yeah.
Yeah. Mr. Abhijit Gavi has asked another question coming up is what would be the message for today's young engineers you would like to pass on after working on such a prestigious project?
See, the basic point is simple. See, is uh, please get into the details. I always use the phrase luxury is in the details.
Mhm.
Suppose I take you to a five-star hotel and then I ask you to stay here and you don't feel anything, then you can as well sleep in a dormitory. You know, I mean, you should feel the sense of the cloth, how fine is the cloth, how crisp is the towel, what is the
Mhm.
scent of the soap. And if you don't feel all those things, I mean, whether you sleep on dormitory or five-star hotel doesn't make any difference.
Absolutely, sir.
So
Absolutely.
the real luxury is in details, and it gives lot of satisfaction at the end of the day. I would
Yeah.
request all engineers should develop the habit of getting into details. And in fact, today there are very few people who are getting into details. We are in the habit
Mhm.
of getting into. We are all. Everybody wants to become managers,
Mhm.
and
And especially in today's AI, which is coming up,
yeah.
where
But
engineers
one
are
thing I'll tell
drafting the
you.
letters, emails using AI.
But I tell you one very interesting thing. See, civil engineering
Okay.
is real. It is not
Hmm.
augmented reality or virtual reality. If I say I am giving you glass of water, I really give you a glass of water and you drink and your thirst will be quenched. It is not like
Oh,
augmented reality. You know, some glass
yeah.
will come, water will come, then finally you drink also, but your thirst will remain the same. No,
Correct, correct,
that is the difference between civil engineering and all these things. Don't, I mean, these are all good up to some limit. But
correct.
real engineering is real engineering. You cannot produce with all these things. I mean, you cannot satisfy hunger, you cannot satisfy thirst by
Yeah.
all these things.
So your I mean bottleneck or the bottom line messages don't neglect the detailing part of it.
That is very important. And another thing is very, very important. Your basics should be strong and don't, the basics are same for all of us. 2 into 3 remains the same for me, Mr. Vivek, or for you, or for anybody. Even I understand 2 into 3 is 6 only. It cannot be a different number.
Absolutely. Absolutely.
So
Sir,
you
I
start from
remember
basics.
here. Yeah, I remember one small basics which you had taught me in 2009 is when I was working on Engineers Day invitation card, you said ki, why you have written engineers, that apostrophe should be after S because there are many engineers day, not a single engineer. So such a small things.
Okay, I don't
Great.
remember good.
There
But
are
if
there are
people
no
ask me,
compliments. Ah, yes, sir. Please
if
continue.
people ask me what is your strength, even today I will
Hmm.
tell. People ask me what are you good at? Are you good at designs? You are good at geotechnical engineering? Or you good at fabrication or this? I always say I'm not good at any of these things.
Oh,
I told
then
I told my CEO, Mr. Subramaniam, when he asked, I said I'm not good at any of these things.
oh my goodness.
But my strength is I can work from principles, first principles,
Ah,
and for me nothing is difficult.
yeah, yeah.
I mean, when I speak to you, this presentation gave you this presentation. I mean, in a very simple terms, that means I have put in so much of effort to bring it to that level for me to understand, first of all, to teach you.
Absolutely, absolutely.
So that is all working from the first principles. Basics should be strong. You should, for that you
Yeah,
have to get into the details.
yeah.
And I like to tell all the people, I very much impressed with the brand pillars, four brand pillars of HCC.
It's
I
easy.
worked
Yeah.
briefly at HCC. They have four brand pillars.
Mm.
The first one is uh, think big. If you get any idea, don't leave it. You know, think big about it. And if you want to think big, then think big, and you have to work.
Mm.
And how you should work with what is called, you should be obsessed with the details. Unless you are obsessed with details, you can't make think big and work on it. And once, for you to work on uh, for you to be obsessed with details, you must have passionate commitment. And if you have passionate commitment, work with and obsessed with details, and you think big, then what you produce is a world class product.
Oh,
These are the four brand pillars, and you must listen this explanation by Mr. Ajit Globchan. He
Gulabchan.
spoke
Yeah.
very nicely what are his brand pillars and what it is. So I think that forms basis for all of us,
All
whether
of
we work
us.
in HCC, AFCONS or anywhere. In life
Yeah.
also, they
Yeah.
work.
Yeah. So great presentation, sir. I think there are no more questions coming up. If there are any questions coming up, please feel free. You can use our WhatsApp group after presentation also till evening. If you compile, so I will just compile those questions and I will share it with Srinivas sir, and we'll ensure that you get the answers to your questions. If at all you are not having any questions right now, there are few compliments coming from ICC President Hemant Vadalkar ji saying outstanding project and excellent presentation. Then yeah, there are few more. Ms. Shri Rohit Chauhan ji is saying thank you very much for a valuable experience and insight. Tanuja madam is saying excellent presentation, difficult project. Yeah, so I think we have covered all the questions, and if, as I told you, if there are any more, please feel to drop in our WhatsApp chat. I will compile them by evening, and I'll hand it over to Srinivas sir, and we'll ensure that you get answers to them.
Yeah.
So, on behalf
So
of ISSE student chapter, I formally thank Srinivas sir. He has given an excellent presentation, and the entire recording of the presentation will be shared on YouTube channel. So, I'll share it to you in by evening or maybe by tomorrow morning. So, I announce formal closure of the session. Thank you.
thank you all. Thank you. Thank you, Vivek. Bye.
Bye.